Hi, in the following videos, we will be talking about the first chapter, which is about data representation. So let's take a look at what we will cover in the whole chapter. In the first section, we're going to talk about number systems, which is about denary, binary, and hexadecimal number system. Also, the arithmetic operations of positive 8-bit number, and 2's complement notation to represent positive and negative binary numbers. And in the second section, we'll be talking about text, sound, and images, which is about how and why a computer represents text, sound, and image. And in the third section, we'll be talking about data storage and compression, which is about how data storage is measured and the purpose of and need for data compression. So let's get started. In the first section, we will look at the number systems. Data representation in computers uses binary systems because it aligns well with the physical properties of electronic components, especially switches. The binary system uses only two digits, 0 and 1, which correspond perfectly with the two states of electronic switches, off and on. Usually, on position is represented by 1, while the off position is represented by 0. The simplicity allows for easier implementation and manipulation of data within electronic circuits. So let's take a look at different number systems. The system that we usually use in our real lives is the denary system, which counts in multiples of 10. Let's look at an example of the representation of a denary number system. Here we can see that the number 1234 is composed by 1 10 to the power of 3, 2 10 to the power of 2, 3 10 to the power of 1, and 4 10 to the power of 0. And we can see that these numbers all have the base of 10. So the denary number system is also called as a base 10 number system. And as we mentioned, the computer usually uses the binary system. So let's take a look at the same example about the number 1234 represented by the binary system. So we can see the table here is the representation of the binary system of the number 1234. Like the denary system, the binary number system is composed by the powers of 2. So the number 1234 is composed by 1 2 to the power of 10, 1 2 to the power of 7, 1 2 to the power of 6, 1 2 to the power of 4, and 1 2 to the power of 1. And we can see that the summation of these 5 numbers is the number 1234. So the way that we convert from binary to denary is by adding numbers where the value 1 appears in the column. So we can see that by adding 1 2 to the power of 10, 1 2 to the power of 7, 1 2 to the power of 6, 1 2 to the power of 4, and 1 2 to the power of 1, we can get the number 1234. So let's have a small exercise about converting from binary to denary. Try to convert the binary number below into the denary number, and the answer will be in another video, so you can pause the video and try it by yourself. So we have learned how to convert from binary to denary, and now we are going to learn how to convert from denary to binary. The first method, we can use subtraction, which is by subtracting the largest possible power of 2 until the value 0 is reached. So let's look at the example. Let's take 395 for our example. We can see that 395 is smaller than 2 to the power of 9 but larger than 2 to the power of 8. So what we will do is we will subtract 2 to the power of 8 and we will get 139. So the second step, we will find that 139 is smaller than 2 to the power of 8, but larger than 2 to the power of 7. So we will subtract 139 by 2 to the power of 7 and we will get 11. And we will keep doing this until we reach the value 0. And the number 1 in the last is 2 to the power of 0. So we can know that 395 is composed by 2 to the power of 8, 2 to the power of 7, 2 to the power of 3, 2 to the power of 1, and 2 to the power of 0. And we'll fill in our results in the tables and we can get the binary representation of 395. And the second method, we can use division, which is by dividing the number by 2 and get its remainder. So let's take a look at the example. We also take 395 for example. First, we will divide 395 by 2, and we will get its quotient and remainder. And then we will keep divide the quotient we get in the last result by 2, and we will get its remainder and quotient. And we will keep doing this until the quotient equals 0. And then we will look at its remainder. So the first remainder we get, we will place it in the lowest digit. And the last remainder we get, we will place it in the highest digit. So let's place it in the table. So we will get the table like this. And this is the representation of 395 by the binary system. And this is the same as the result in the first method. If you are curious about why this method works, you can look at this side. We can break down the number 395 into these powers of 2, and every line represents the division, what we have done in the second method, and we can find the composition of the powers of 2. So let's have a small exercise. Try to use the two methods to convert the number 841. And I'll also put this answer in another video. So let's have a review about what we have learned in this video. We have learned the binary and denary number systems and the conversion between the binary and denary number system. And in the next video, we will look at another number system, the hexadecimal number system.